Okay, so we are going to start talking about geometric and algebraic proofs. So we just talked about algebraic proofs and what to do and how to explain your reasons for every step. And this first one's just going to be a warm-up problem, and then we are going to get more into the geometric type of ideas as well. So for these notes, it says complete the following two-column algebraic proof. Given that 3 times x plus 4 equals 5x minus 8. Well, that is our first step, so that one is going to be given here. Remember, whatever we are given up here is the first line in our proof. Then we have to look from this step above it to step 2. So for example, I'm looking from step 1 to step 2 and asking myself, what did they do? What is different about it? So here I can tell that they multiplied in the 3 into the x and the 4, so that became 3x plus 12. Well, that is the distributive property. And then over here again, from step 2 to step 3, what happened? So it looks like now we have this 2x, and I don't see this other 3x on this side. So they must have subtracted 3x over. So that is the subtraction property of equality. And again, if you all need to take some space on the other side and solve this equation out for yourself so you can see a little bit better what is happening from step to step, then I would definitely do that. And then here, this 8 is no longer around, and the 12 became 20, so they're adding 8 to both sides. So that is the addition property of equality. And then we went from 20 equals 2x to 10 equals x, so they divided. So division property of equality. And we just flipped the order around because remember I said that it needs to look exactly like the statement you were trying to prove. So I need to have x come first and then 10 last. So we had to flip that around. So that is the symmetric property of equality there. And then we are finished. Okay, this next step, we are filling in a proof all by ourselves, so there's no lines given in here, which is okay. But we are going to always look to see where you are headed in a proof. So the first statement, I'm going to go ahead and say that measure of angle 1 is equal to measure of angle 4, and that is given. And then I'm asking myself, where am I going with this? I am proving that two angles are congruent. Well, I know that measure of angle 1 is equal to measure of angle 4, so those two angles are congruent right there. I'm going to put my congruent sign in there. So I know I probably have to do something with linear pairs here, so I'm going to go ahead and put in my linear pairs. So measure of angle 1 plus measure of angle 2 equals 180, and that is the definition of linear pair, because we know a linear pair adds up to be 180 degrees. Then I'm going to do the same thing with measure of angle 3 and measure of angle 4. So measure of angle 3 plus measure of angle 4 equals 180 degrees. And again, that is the definition of linear pair. And they are both set equal to 180 degrees. Since they are both set equal to 180 degrees, I can set the measurements equal. So I can go ahead and say that measure of angle 1 plus measure of angle 2 is equal to measure of angle 3 plus measure of angle 4. Okay, so that is going to be the transitive property. And again, they're both set equal to 180, so I can go ahead and set the other side of the equation equal to each other. Here, I know that measure of angle 1 equals measure of angle 4, so I'm going to go ahead because I need to have 2 and 3 left over at the end. So I'm going to replace either measure of angle 1 here with measure of angle 4 or measure of angle 4 with measure of angle 1. It doesn't matter which one you do. I'm just going to replace measure of angle 4 here. So that changed, and I'm replacing that because of my first line. And then the rest of it is going to stay the same. Okay, and then I see that measure of angle 4 is on both sides, so I can go ahead and subtract that. Oh, that was substitution. And then again, I can see measure of angle 4 is on both sides, so then I can get rid of that and say that measure of angle 2 equals measure of angle 3. And I use the subtraction property of equality. And then it needs to look like my very last line, so then angle 2 is congruent to angle 3, and that is the definition of congruence, because I know if their measurements are equal, if they have the same degree measure, then the angles are congruent. Okay, so that one was a little harder because we are filling it all in. You will have to do some of those, not very many, but I might have you complete some proofs all by yourself. So flipping over to the back, this one's nice because they're giving us some guidance on where to go. So here, point B is the midpoint of AC, and then point C is the midpoint of BD, and we are proving that segment AB is congruent to segment CD. Okay, so the first line says B is a midpoint of segment AC. That is given to us. And then the next line, the reason says definition of midpoint. So they're trying to tell us to go in the direction of saying that if B is a midpoint of AC, then AB is congruent to BC. So now I'm going to go ahead and say that AB equals BC. Next line says given, so I'm guessing I'm rewriting that point C is the midpoint of segment BD. Kind of repeating the same pattern, so then BC equals CD, and I'm going to repeat the same pattern and say that is the definition of midpoint. And now I see that BC and BC are being repeated, so then I can set the other two equal to each other. So AB is equal to CD, and that is the transitive property. So we're cutting out the middleman there. And again, it needs to look exactly like the last line that we were trying to prove. So instead of AB equals CD, I need to say that segment AB is congruent to segment CD, and that is the definition of congruence. Because I know if two lengths are equal to each other, then those segments are congruent. All right, and then the last one, we are given that angle 1 and angle 4 are a linear pair. So if we look in our picture, angle 1 and angle 4, we can see that they are a linear pair. And we are also given that measure of angle 1 plus measure of angle 3 equals 180 degrees. And we are trying to prove that angle 3 is congruent to angle 4. So angle 1 and angle 4 are a linear pair. That is given to us. And I try to think about, and the next reason says definition of a linear pair. So I know linear pairs add to be 180 degrees, so I'm wondering if that's what they're wanting us to do. So measure of angle 1 plus measure of angle 4 would equal 180 degrees. Next line says given, so let's plop our given up in there. Measure of angle 1 plus measure of angle 3 equals 180 degrees. Again, they're both set equal to 180 degrees, so let's go ahead and set those lines equal to each other. Measure of angle 1 plus measure of angle 4 is an equal to measure of angle 1 plus measure of angle 3. And I see that measure of angle 1 is being repeated. That was the substitution property. Measure of angle 1 is being repeated, so then I can say that measure of angle 3 is equal to measure of angle 4, and that is the subtraction. Property of equality, and then the last line needs to be what I'm trying to prove, so I'm trying to prove that angle 3 is congruent to angle 4, and that is by definition of congruent or congruence, because I know if the measurements are equal, then the two angles are congruent.